Okay, so this is now part two of section 7.2. Okay, now starting to continue on with the lesson. It says given the following parabola, graph the absolute value of this function. Okay, so whenever you're given the parabola, again when you so this is like y equals to like x squared minus 4 per se, right? Or something close to that. Minus b then, okay, minus 4 whatever. And then if you were to graph the absolute value of this function, so you put an absolute value sign, what you do then is any part that's underneath the x-axis, so this part over here, gets flipped over the x-axis, so it goes on top. So the absolute value of this graph now will look like this. Okay, so anything that's underneath now goes on top. So this is the graph of the absolute value of your previous function. Okay. So next thing is you're going to be given two equations here. Okay. So if you look at these two equations, y equals to the absolute value of x squared minus 4, and the second one is the absolute value of x squared minus 4. The question is, how are these two equations the same, or how are they different? Okay. Now, obviously, they're the same in the aspect that they're both absolute value graphs, and they're different because the negative 4 is outside, this one's inside. Okay. So what happens when it's outside like this? So what you would do is you would take the absolute value of the parabola first. So you have like y equals x squared. You take the absolute value of that, and then what you do end up afterwards is you shift the whole graph down 4. So it will look like this. Here's your absolute value graph. You take the absolute value of it, nothing happens. And then you shift down 4, it will look like this. That's the first graph. Second one, because of bed mass, you would take the parabola, you shift down 4 first. So you would shift the graph 4 units down, so the parabola will look like this first. And then you do the absolute value after that. And so what happens is this part underneath gets flipped over, so your graph actually looks like this. Okay? So that's how these two equations are different. Okay? Next slide. So given the following graphs, graph the absolute value of each function. This one should be pretty straightforward. Again, anything that's underneath the x-axis is now flipped over. So like the left side becomes the blue. This part over here goes on top, and then like that. Okay? Second one is the same thing. You take this part out away and you move it over, flip it upside down, and this part over here is flipped upside down. Okay, so a pretty straightforward question. Okay. Next one. Okay, which of the following is the correct piecewise function for this equation? Okay, so you have A, B, C, D. All right. So first thing I would do is you would graph the original equation. So it looks something like this. Okay, so this equation here. Let's look inside. Y equals to 2 over 3x minus 6. Right? So you notice how your graph is y-intercept is negative 6. So 1, 2, 3, 4, 5, 6. Your slope is 2 over 3. So you go up 2, right 3. 1, 2, 3, up 2. And then 1, 2, 3, up 2. 1, 2, 3. Okay? So your graph will look something like this. And if you count it right, this is actually 9 over here. And then what you do next is anything that's underneath the x-axis is now flipped upside down. So it looks like this. Okay? So this is the graph of y is equal to the absolute value of 2 over 3x minus 6. But what happens when you put a negative sign in front afterwards? You see how this has a negative sign? So what you do is then this whole parabola is now flipped upside down. So instead of going up, now it goes like that. It goes down like this instead. Okay, so there's my graph. Okay, this is the graph of the absolute value with a negative sign in front. Now, when you look at the choices, you know you're gonna, when you write your piecewise, you have to use your x-intercept of 9, right? So that means that C and D are both wrong because your piecewise is being split at 6 and negative 6. That's wrong. So the choices you have right now is either A or B. Okay, and then what I'm gonna do next is let's look at this original graph. Okay, how it looks like. So negative 6, so 1, 2, 3, 4, 5, 6. Slope is 2 over 3, so 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Okay, so here's my graph. Okay, so when you look at the options, right, you have 2x minus 2 over 3 times x minus 6, and then when you compare this graph with the absolute value at the end, can you see how it was the right side that got flipped over like that? So So what that means is the left side, it stays the same. It's the right side that was flipped. So therefore, when you look at the options, you see how you have 2 over 3x minus 6, 2 over 3x minus 6 for all the options. And since it was the right side that was flipped, you put a negative sign in front of the right side. So therefore, the answer would then be A. I hope this makes sense. If it doesn't, send me an email and I'll do a better job explaining it. Okay, next one. Okay, so how do you write a piecewise function? Okay, so hopefully after this slide, everything will make sense to you. A piecewise function is an equation where you split the domain into separate pieces, okay? And you separate them based on the x-intercept, okay? For each separate domain, your equation will use a different formula, okay? And here are the steps. Number 1, find your x-intercepts of the parabola, okay? And use the x-intercepts to separate your domain as left, middle, and right, okay? And the reason why you have left, middle, and right is because there are 2 x-intercepts, okay? And you write the equation inside the absolute value to the left of each domain, okay? So after you put down left, middle, right, on the left side, you write out what was inside the absolute value sign, okay? But don't write any absolute value signs in your piecewise function, okay? And what you do next is you graph the parabola and you indicate which part was flipped upside down from the equation in the middle, okay? And then the part that was flipped upside down, you place a negative sign in front of the equation, okay? Now let's go through an example. Hopefully, you can take a picture of this slide, copy it, and then we'll look at an example together. Okay, here we go. So you're given 3 equations here. A was, number 1, you want to find the x and y intercepts. Number 2, find domain range. And the most important thing is find the piecewise function. And you're supposed to graph each of the following. Okay? So here's A, B, C. Now feel free to pause the lesson, take a picture of it, do the question, and then when you're done, press play. Okay, so I'm going to pause it right now. Okay, here we go. Let's do A together. So let's move on. Okay, here we go. First one. Find your x and y intercepts. So A, what I would do is, I'm going to factor this. I'm going to treat this as like y equals to x squared minus 6x plus 5. So when I factor this, you'll get y equals to x minus 5, x minus 1. So your x-intercepts will be x equals to 5, and then x equals to 1. Okay, so 1 and 5 are your 2 x-intercepts. There's 1, and then there's 5. Okay, and the next thing is, you see how there's a 5 at the very end? That means your y-intercept is y equals to 5. Okay, so 1, 2, 3, 4, 5. Okay, and since it's symmetrical, I'm going to put a 5 over there as well. Okay. Now, next thing is I want to graph this. So if you're looking for the axis of symmetry, I hope you remember this where it's always going to be x equals to negative b over 2a. So this is the equation for finding the axis symmetry. So when we go back to the equation, a is 1, b is negative 6, and c is 5. So that means that x equals to negative 6 over 2 times 1. You do the math for this, becomes 6 divided by 2, so 3. So x equals 3 is your axis of symmetry. Okay, so your graph will look like this. And then if you want to find your vertex, okay, you plug 3 into your original equation over here. Okay, so y equals to 3 squared minus 6 times 3 plus 5. And you'll get 9 minus 18 plus 5. So you do the math. 9 minus 18 is negative 9, plus 5 is negative 4. So therefore your vertex will just be 3 comma negative 4. So 3, 1, 2, 3, 4. Alright, so your parabola will look something like this. Okay, I'll do a better job graphing this out. Comes down and then goes back up like that. Okay, there's the original parabola without the absolute value sign. And then what I'm going to do next is I'm going to take the absolute value of this parabola. So what happens is the middle part that was underneath, what happens now is it goes back up. It gets flipped upside down. So this is like negative 4. So you go 1, 2, 3, 4. It goes on top. Oops. So it looks something like this. And it goes back up. So here is my graph. Okay. Domain is always a freebie. X can be all real numbers. Your range, also another freebie. Y is greater than or equal to 0. And the main thing that's hard is your piecewise now, okay? So I'm going to write my piecewise over here. Y equals 2. Now, when you write your piecewise, you have to use your x-intercepts. And you're going to break into 3 parts. Left, middle, and right, okay? The left side, okay, here's your first x-intercept. X equals 1. So this part over here is x is less than 1, okay? The middle is going to be between the 2 x-intercepts, so between 1 and 5. So x is greater or equal to 1, but less than 5. The right side is where it's going to be to the right of the second x-intercept. So x is greater or equal to 5, okay? Now what we do next is you look inside the absolute value. Here's the equation, okay? And I'm going to write that equation, in all 3, steps. So x squared minus 6x plus 5, semicolon, x squared minus 6x plus 5, semicolon, x squared minus 6x plus 5, and a semicolon. And now what you do next is you ask, hey, which part was flipped upside down? The left, middle, or right? And the answer was the middle. So what you do is you put a bracket around the middle equation, and you put a negative sign in front, and that will be your piecewise function. And what it's saying is, when you look at the left and the right of the graph, you would graph the same thing as this parabola. But in the middle, you would have to put a negative sign in front, indicating that to graph this absolute value function, the middle part would be flipped upside down. Okay, and that will be your graph.